Let's turn, though, to a fascinating story because scientists have discovered a gigantic ring-shaped structure in space which is so big it challenges our understanding of the universe. Experts at the University of Central Lancashire say it's 1.3 billion light years in diameter and appears to be roughly 15 times the size of the Moon as seen from Earth. Structures that big shouldn't exist, according to one of the guiding principles of astronomy. Well, I'm delighted to say let's speak to Alexia Lopez, the PhD student at the University of Central Lancashire who identified what is being called the Big Ring. You are smiling broadly. I'm not surprised. I mean, what does it feel like making a discovery like this?
Yeah, I mean, it's amazing. It is surreal. We stumble across these discoveries accidentally, so it's so fun to be able to, write up analysis on these kind of discoveries. So yeah, it's really exciting.
Now, my brain is clearly smaller than yours, so you better just explain in simple terms what you've actually discovered.
So I've discovered a really massive structure in the universe. So these are the biggest things in our universe. So it's made up of galaxies and galaxy clusters, and it creates this really big ring shape.
And how did you find that? Because it's pretty obvious nobody else has stumbled across this. So how did you actually do it?
Yeah, so I was using a relatively unique tool to find this large scale structure. So the method uses these really bright sources of light known as quasars. And then when we measure the light from these quasars, it can tell us about things that are in between the quasar and us. So when I measured, I use all these quasar spectra. And so it tells us about all these intervening system. So it tells us about where these galaxies are. So you can imagine it's kind of like looking at bright spotlights in a dark room. So the spotlights are highlighting to us where all these galaxies and galaxy clusters are. So without the bright spotlights, without the quasars, we would usually not be able to see these galaxies and
Yes.
galaxy clusters.
So that's how you did it. Just again, in simple terms, explain why it challenges what we thought we knew.
Well, in order to make the mathematics simple, to model our universe, we make some assumptions. And one of those assumptions is that on large scales, we should see that the universe and the matter distribution in the universe looks smooth everywhere. So this essentially puts this limit on how big we should find structures existing. So when we find these large scale structures, these huge large scale structures like the Big Ring or the Giant Arc, these are so big that we're now not seeing this statistical homogeneity. We're not seeing this smoothness in the universe. So it does challenge this cosmological principle. It challenges our founding assumptions on what the standard model is built on.
So if those absolutely basics that we thought we knew aren't necessarily what is actually the truth, what sort of questions then get thrown up?
Well, I mean, this is the biggest question. What do we do now? Really, we need to start thinking about if we should be using alternative models of cosmology. So these are proposed by lots of different people, including a Nobel Prize winner, Roger Penrose. So he has his alternative theory of cosmology, which actually you would detect circular features in the sky, in the CMB sky. So maybe it means we need to start really taking these alternative theories in cosmology seriously, and also seriously be questioning whether our standard model can hold if the basic assumptions are proving to be challenged.